Section 3.7, it's titled Rates of Change in the Natural and Social Sciences. What we're going to see now is an application of the derivative functions for different functions in different contexts. So it's widely applied in physics and biology and in economics. So we're going to see those examples later. Let's talk about the most common one. It's applied in physics, and it's actually in both exams, the ECE and the AP exam. So we have some particle that is moving along the x-axis, whose position is given by a function that happens to be a cubic function, where t is the time measuring seconds and s is the position measuring meters. So imagine a number line where every unit is 1 meter, and then we're probably going to move along on the positive side, but we can talk about the negative side as well, but every slot here is measured as 1 meter, so we can have negative position, however the distance is always positive. Okay, so you can follow along with the handout that you have. I'm not going to write down the question. You can also look at that in your book. It says part A, find the velocity at time t. So that just implies that I have to find v of t. I have to find some formula that gives me the velocity at any given time. So the only thing that I have to remember is that if I know the position of a particle, I find the velocity by taking the derivative, because it will be just the change of position over a period of time. So change of position over change in time, that's velocity. And then the velocity at any given time would be when that change in time is very, very small, and we're taking the limit of that. So that makes us take the derivative of this function. So I'm just going to take the derivative of the position. In this case will be 3t squared minus the 2 becomes coefficient, and that makes 12 t to the 1 power plus 9. Now the units of this velocity, since it's the rate of change, it will be the y units from the previous function over the x units of the previous function, which in this case is seconds. So I know my velocity is going to be meters per second. 1 second. Okay. So I found part A, that's the function velocity at every for any given time. Now for part B, it says what's the velocity after 2 seconds and after 4 seconds. So velocity after 2 seconds will be given by v of 2. So that means I just have to replace 2 instead of t all along, not only for the first term but all the other terms as well, wherever I see t. So with my mental math, I figured that this is -3. Since it's velocity, I must put the units, so please don't forget to put the units whenever you're answering questions like this. And the velocity after 4 seconds is just simply v of 4, and I'm going to replace that and figure it out what it is. With my magic calculator, I discovered that it's 9 meters per second. So at different times the velocity changes, so we're probably going to talk about some kind of acceleration function. If the velocity was the same all along, then you know that the acceleration will be 0, because the rate of change of velocity over time will be 0. But you see it's different. So the other thing that you may notice here is that the velocity here is negative, and in 4 seconds is positive. So that only means if you were the particle inside a particle car, you will see in the speedometer, you will see just 3 or 9 without the signs. Remember that the signs only talk about direction. For part C, it says when is the particle at rest. So that's a piece of information that it translates as follows. At rest means the velocity is 0. So we just have to find out how much is t, so that v of t equals 0. So I'm going to take v of t, 3 squared minus 12t plus 9 should equal 0, and I'm going to factor. Now I notice that there is a common 3, so I factor out the 3 and I have the following. And then I notice that this can be factored out simply. I don't have to use quadratic formula or anything like that. Into t minus 1 and t minus 3. So 3 cannot be 0, but t minus 1 can be 0, so t is 1. And t minus 3 can be 0, so t can be 3. So I know that at 1 second, at the first second, and after 3 seconds, the particle is at rest because the velocity is 0, and I don't have to check anything else. Now for part D, the particle moving forward or moving on a positive direction. Remember that if you are the particle and you are traveling on the number line and you have your particle mini car with a particle speedometer that max from 0 to whatever, I don't know, 60 or something, whether you go left or right, it doesn't matter to you because you will always be able to see your speed. However, velocity is positive when you're going right, and velocity is negative when you're going left, and that is just an agreement. Velocity is speed with direction. So the particle moving forward or moving in the positive direction implies that the velocity is positive. So I know when the velocity is 0, I know velocity is 0 at 1 and at 3. Not in terms of position, but in terms of seconds. Okay, so I just want to know the sign of the velocity between the beginning of time, which is 0 seconds, between 0 and 1, between 1 and 3, and after 3 seconds. Okay, so velocity being 3 times t minus 1 times t minus 3. I'm going to pick a number between 0 and 1 just to make sure that I'm calculating the correct sign. So 3 is positive, t minus 1. If I'm picking a number less than 1, t minus 1 will be a negative number. And picking a number between 0 and 1, then quantity t minus 3 will also be negative, let's say 0.5. So 0.5 minus 1, negative 0.5, that's a negative number. 0.5 minus 3, that's also a negative number. But the multiplication of negative and negative makes it positive. So this velocity will be positive between 0 and 1. Now between 1 and 3, let's say 2. So 3t minus 1, t minus 3. 3 is positive. If I'm picking 2, 2 minus 1 will be a positive quantity, but 2 minus 3 will be a negative quantity. So between 1 and 3, this product will be negative. So the velocity is negative here. Velocity is positive between 0 and 1, is negative between 1 and 3, and then let's see after 3. Let's pick a number bigger than 3, like 4. So I'm going to investigate how the signs change. Now this is positive. 4 minus 1 is positive. 4 minus 3 is still positive. So this as a product is positive. Therefore, the velocity is positive after 3 seconds. Also, if you look at the equation, b of t equals 3t squared minus 12t plus 9. This is a quadratic with zeros 1 and 3. And because the a is positive, it's going to open up. So if I remember this, also I can see that the velocity is positive between 0 and 1, and it's positive after 3, and that is negative, meaning under the x-axis, it has negative y's. This is negative between 1 and 3. So I can also see it this way, or I can see it this way. So anyhow, when is the particle moving forward? When the velocity is positive, and the velocity is positive between here and here, and after 3. So formally, how do I write that? So I can say let me see. Okay, I can say t between 0 and 1 the velocity is positive, so the particle moves forward. And for t bigger than 3, v of t is also positive, and the particle moves forward. Sometimes you may see in some textbooks that they close here, they use closed intervals. T could be 0 and the velocity is still positive, so you can include 0. But we're gonna prefer to leave it open at the end. So in here it should be open at 1, and in here it should be open at 3. That's why I'm not writing greater than or equal. I'm just leaving at greater than. Now for part E, we have to draw a diagram showing the motion of the particle. So remember that the particle moves along the x-axis, so the position could be on the positive side or on the negative side. And also at the beginning of time, we cannot assume that the particle is at 0. The particle may start at 2 or at 5 or at 112, any random number. So how do we know where the particle starts? Well, I want to know at time equals 0, how much is s. So when I replace in my position equation, I notice that actually s is 0. So the beginning, the particle is right here. So at time 0, s is 0. Okay, that's the beginning. Then remember that we said the velocity was positive between 0 and 1. So I know that the particle moves forward. So I know it goes in this direction. And remember that we saw that at 1 second, the velocity was 0 and the particle stopped. So at 1 second it stopped, but it doesn't mean that it was at the position 1 on the number line. I have to find out what is s for the time equals 1. So when I replace, I have 1 cubed minus 6 times 1 squared plus 9 times 1. And that number is 4. So I have 1, 2, 3, 4. The particle goes all the way over here and it stops. Okay? Now when a particle stops, it may continue this way or turn around. Now remember that after 1 second, the particle doesn't move forward, then it moves backwards. So I know that it's going to turn around. But on the other direction, I don't know when is it going to stop. So you remember that it also had velocity 0 at time 3. So I know that at the 3rd second it's going to stop. But how much is s for that? I have to figure that out. So it's 3 cubed minus 6 times 3 squared plus 9 times 3. And that gives me 0. So that means the particle came back to this position. So this is at t equals 1. It stops at 4. Let me just erase this and put it somewhere else so that you can see. So this is t equals 0. And now it stopped over here. After 3 seconds, it went back to its initial position. And I know that for t after 3, the velocity is positive. So that means it moves forward. So I know it changes position. Now I don't need to draw anything else because they don't tell me until when I have to draw. So this is the most interesting part of the particle travel. Now in part F it says find the total distance that the particle traveled. So that's after 4 seconds. So 4 seconds. I just want to know what happened to the particle after 4 seconds. So this is 1, 2, 3. I have to find how much is s when t is 4. Sorry, the question said 5 seconds. I'm gonna correct that and I'll include the new exercise on the next video. Sorry about that.